I began by taking a small amount of skewers and tightly twisting them together with the masking tape. This method ensured that they formed a solid one-piece unit. This was crucial because I intended to cut them using miter saw later. As you can see, the tape worked flawlessly. All the skewers stayed in place, resulting in perfectly flat ends. Once sorted from largest to smallest, the tape was no longer needed. Next, I randomly selected several sticks of different lengths and arranged them in a pre-made jig with a width of 10 cm. The intention was to create a wavy shape using the pointed ends of the skewers. Once the surface was covered, I removed one full-length wooden skewer and replaced it with a few smaller pieces, creating a small window that will be filled later. I repeated this process 4 times on a single flat piece. To ensure the skewers remained in place, I crafted custom holders from plexiglass. These holders helped me press and secure all those loose wooden skewers perfectly flat. To permanently fix them in place, I used high-viscosity CA glue, applying it drop by drop between each skewer in different lines. After spraying CA activator, I obtained a perfectly flat and solid sheet of wooden skewers. Although it is flat and solid, it remains somewhat fragile. Therefore, I placed it back into the jig and added another layer of skewers using slightly thicker CA glue. This additional layer increased its strength, making it suitable for my intended purpose. Behind the camera, I repeated this process several more times until I obtained 4 longer and 4 shorter pieces. Next, I took a rotary tool with around 3 mm in diameter carving bit. I used it at an angle and made a hole in every formed recess end. Okay, here's where things get more interesting. This neon electric wire / strip is going to be used in this build. It can be powered by a pair of AA batteries, a USB port with the help of an adapter, or any other device that has the USB port. The beauty of this wire really shines in the dark rather than in the daylight. It is quite impressive because it is flexible and can be shaped in any way you want. Plus, you can cut it at any point and it will still works. So it is perfect for various projects of different sizes. I plan to use the entire 10 meters length of this wire. The idea is to thread it through all the holes, starting from the larger piece and finishing at the top of the smaller one. I removed end cap of the neon wire and inserted into the first hole. The process is similar to tying your shoelaces, except after each new hole I had to pull out all those 10 meters of neon wire. Hole by hole I completed the first piece. The neon wire flexes and extends above the flat surface, so I added a few drops of CA glue and secured them as deep as possible. Its purpose will become clear later on. For now, I need to continue running more wires through the remaining holes. This process was quite time-consuming. What you see here is one piece being wired in a couple of seconds, but in reality it took me on average of 6 or 7 minutes. Once the larger parts were finished, I moved on to the smaller ones. Here new challenges emerged. The gaps between the formed recesses were shorter, requiring more aggressive bending of the neon wire. On the other hand, the total length of the wire becomes shorter with each pass, so I had to pull less wire through each hole, what makes this process progressively faster. After wiring all wooden skewer sheets, I placed them in a custom-made plexiglass jig. This jig will help maintain an accurate and rigid form while I fill it with the wooden skewers all the way up. I will be using the same wooden skewers leftovers from the previous glue-up. But before that, I need to cut them in shorter pieces. I've created 3 different lengths to provide plenty of options for the filling application. You will see what I mean in just a minute. Now the process becomes quite challenging because each piece needs to be individually picked up with tweezers and placed on applied CA glue. The different lengths of the skewers become more apparent here as they follow the desired wavy pattern while passing over the wired neon wire. Every few rows I place neon wire from top to bottom and vice versa. This will create visible glowing wire segments once everything is completed. While it may seem like one row is filled in just a few seconds, in reality it took me several minutes to accomplish. At some point I anticipated this to be time-consuming, but I underestimated just how labor-intensive it truly is. Nonetheless, this idea has been in my mind for over 2 years, and I cannot abandon it halfway through the project. That's what I'm thinking at this point. However, what will become evident later on is that the midpoint was much further ahead than I initially thought. Row by row, I continued gluing and adding the neon wire every few rows of skewers, slowly making my way to the top. The neon wire gradually became shorter until it was bent and glued for the final time. The last row of skewers was placed in alignment with the top cover to bypass the wired neon wires and allow the top to sit flush in its place. At this point, it's taking on a really nice shape and represents about 60% of the final look. It took a considerable amount of time to achieve desired wavy form with pointed wooden skewers ends, but looking at it now, I'm 100% satisfied with the outcome, considering the effort it required. Before attaching the top cover, I need to fill this compartment, and as you may have guessed, I'll be using the same wooden skewers. It is a repetitive process of skewers and glue, layer by layer, until it reached the top. You may notice that I'm utilizing various lengths of leftovers, but that won't make any significant difference since I'll trim them flush with a single cut later. A final line of C glue secures the top cover in place permanently. For the bottom part, I took a slightly different approach. I used a walnut leftover and shaped it as closely as possible to follow the line of the glued skewers. I sprayed it with a few coats of clear to seal the wood. That's why the piece is so shiny. By placing it inside, I achieved 3 benefits. First, reduced the amount of epoxy needed to fill the space, which is more cost-effective. Second, decreased the volume of epoxy, reducing the risk of thermal runaway and unpleasant reactions. And third, created a 3 cm deep pocket underneath for later installation of the electronics. Lastly, I wanted to cover the exposed neon wires at the bottom. Although they will be covered by bottom lid and won't be visible when the lamp is standing, I strive to meet my personal quality standards. Therefore, I glued a few rows of leftover skewers on each side. And finally, the wooden skewers glue-up saga comes to an end. Carefully removed from the jig and created the mold using 5 mm thick plexiglass. I intentionally used slightly oversized plexiglass sheets to provide an extra surface area for sealing the glue joints and achieve a watertight seal. Now let's move on to the bottom part. Here I used a small box that replicates the niche formed at the bottom of the lamp. The bottom part finalized the mold. The remaining task is to ensure watertight glue-up lines with a fast-drying silicone. That's why I opted for oversized plexiglass sheets. They create a convenient corner for spreading silicone and ensuring a tight seal. Let's move on to the epoxy. I attempt to achieve my desired color by using different amounts of those 2 colors. Some drops of yellow pigment for the beginning. To achieve that radioactive greenish color, I added a few drops of turquoise. Well mixed and let it sit for 20 minutes. I'm using a slow curing deep pour epoxy, allowing any formed air bubbles to escape during this time. And now we have crystal clear epoxy ready to be poured. The pouring process took some time as the epoxy resin was able to flow over the smallest gaps left in the glued wooden skewers block. One more nice fact, I was quite lucky in estimating and preparing the required amount of epoxy in a single mix. It was exactly 2 liters. Bubble after bubble, all the air was pushed out. And yes, this deep pour epoxy works flawlessly. It is liquid as water and all the bubbles escapes naturally by leaving that desirable clear view. 1 week later, the epoxy was fully cured. Quite interesting air gaps formed inside the plexiglass. My guess is that these air gaps appeared due to the epoxy shrinking during the curing process. However, this is not a major issue, and we can easily address it once we remove the project from the mold. Despite not using any mold release agent, the mold came out quite easily. Some parts were removed in pieces, but the surface was left nice and even. Let's get rid of that overfill first. My small miter saw managed that only in 2 passes, revealing a beautiful pattern. Next came the less exciting but crucial part to eliminate small imperfections and at the same time get my imagined look. The goal was to sand it down until the skewers were half opened. 60 grit sandpaper eats it like butter. To enhance efficiency, I occasionally cleaned the sanding belt with a rubber piece designed for such task. Once the rough sanding was completed, I moved on to more precise grits. Starting from 80 grit, I progressed all the way up to 320 grit using an orbital sander and mesh-style sanding pads. If you are working with epoxy, aiming for dust-free work process, that's the way to go. After reaching 320 grit, I continued with even finer grits and hand sanding up to 2000 grit. Unfortunately, no footage was captured during this process. To bring back the transparency and shine, I used 2 buffing pads. I started with the orange one as it is harder and has aggressive polishing features. This is small 8 cm in diameter polishing pad that works perfectly with any drill. As for the polishing compound, I used a one-step polishing product commonly used in the automotive industry. One step means that you start and finish the buffing process with the same product. The difference was stunning. After ensuring that all 4 sides has no visible scratches, I switched to the black buffing pad, which is softer and designed for the final shining step. Using the same buffing compound and a bit of water, I spent approximately 1 minute on each side. And the result looked amazing. To move forward, I need to make 2 pockets in the bottom part. The first one will be used for the on-off switch and the second one for the charging port. Using a 3mm spiral router bit on my palm router and a jig made from the scrap plywood pieces, I created the pockets. Additionally, I drilled a small hole for the wires. Talking about electronic parts, I will be using USB-C female connector as a charging port, a touch sensor switch TTP223, and a 5V relay module. To ensure that everything will work as intended, I set up a quick demo to test the functionality. A green LED indicates that the relay is working. When the touch sensor module is touched, it activates the relay, providing the power to the connected LED strip. However, this particular feature is not what I needed for this project. Taking a closer look at the touch sensor module, it has 2 operation modes, A and B. These modes can be enabled by bridging the corresponding terminals. By bridging the A terminals or leaving them open, the current working function is enabled. To achieve that desired on-off feature, I bridged the B terminals. A quick test confirms that it is working properly. According to the description, these sensors can operate up to distance of 4 mm. However, during my testing, I found that the actual distance can be greater. I tested it with a 7 mm thick piece and it still worked perfectly fine. The beauty of this setup is that this small 5V touch sensor can control powerful AC or DC devices through the relay module. It can handle up to 10 amps in AC and up to 10 amps in DC with a 30V system. Let's mount everything inside the lamp, starting with the charging port. Then placed the touch sensor and managed the wires through the hole. Connected and glued 5V power module to neon strip and glued the relay module in the available space. Soldered and connected wires by starting from the input side and finishing on the output side. All through, I tried my best to make the wiring neat and tidy. It still appears a bit messy. Do you remember the offcut which was created with a miter saw? I sliced a thin piece from it to cover the electronic compartment. To protect the wooden part, I used clear matte hardbox oil from Osmo. There might not be a noticeable difference in appearance, but that's exactly what I wanted, to maintain a natural look as much as possible. And here we have it. The wooden skewers combined with a neon wire lamp is now complete. It is truly a stunning piece that adds a touch of elegance to any space during daylight, as a beautiful home decor element. However, the real magic happens when the lights are turned off and the darkness sets in. In the dark, the lamp comes alive, showcasing its true beauty. The neon wire glows, casting a mesmerizing light that creates a cozy ambience. Overall, I am incredibly proud of the final result. The combination of creativity and the use of unconventional materials has resulted in truly remarkable and visually stunning piece. Thanks for your support for subscribing to the channel. This encourages me keep working on the new projects. Take care and until next time. Bye.